Today we are going to discuss about DFS Traversal. It is a one of the graph traversal, and it is a DFS means depth first search. It is a systematic way to find all the vertices reachable from a source vertex. The source vertex is represented as S. So if there is a vertex is the in a graph there is a source vertex, and there is U, V, W, then X. If this is a vertex, then in this DFS search we have find all the vertices reachable from the source S to sources. And in this DFS search, the process is first we search or process the vertex from first deep, that is here. First it find the one of its adjacent and find the adjacent of this node like this. And after processing a vertex, it recursively processes all of its descendants. So like BFS, to keep track of progress, depth first search colors each vertex. There are three types of vertexes are there, or three state of a vertex are there. First one is undiscovered. That is the disk does not visit edge, then that is known as undiscovered. Then second one is discovered, that vertex is visited but not finished. That means descendants all descendants are not explored yet. Then last one is finished. That means everything reachable from that vertex is found, that is fully explored. And state of a vertex, we can color the state of the vertex. So first undiscovered state will be colored using white, and discovered but not finished state will be represented using gray color, and finished state is represented using black color. And the parent of a vertex V, that is represented by pi of V. And initially if V is a root vertex, then pi of V will be set as nil. Then there is a two timestamps are there, and a timestamp represented based on the color change. And when a vertex V changed from white color to gray color, that is white color is not visited, gray means visited. So this change, when a vertex is visited first time, then is time is discovered by D of V, that is discovered the vertex V. Then when a vertex gray is changed from, the vertex color change from gray to black, that black means all finished state. Finished state indicate that all is descendant that explored. Then it is represented as F of V, that is finished time. So the time represented, there are two types of timestamp, discovered time and finished time. Discovered time is represented as D of V, and finished time of vertex V is represented as F of V. Then algorithm, depth first search algorithm. DFS form a depth first forest comprised more than one depth first trees, and each tree is made of edges UV such that U is gray and V is white when edge UV is explored. So when we find a edge UV, consider the edge UV. In this case, U is gray. U is gray indicate that it is discovered and not finished. V is white. It indicates that this is undiscovered node. Then the following is the pseudocode of a DFS. Here DFS of G, it consists of two subroutine. One is DFS of G and another one is DFS of visit u. First, initially G indicates the graph, and each vertex in that graph, initially the color of the all vertices is white and is nil, parent value will be nil, and time is initialized to 0. For each vertex u in view of G, then we consider vertices one by one in the vertex set. Then color of u is equal to white. If the color of u is, select one vertex u which color is white, then perform the DFS visit of u. That is, this procedure will be started. Then first vertex is visited. If suppose this is the vertex, this is the vertex. Initially all vertex color will be set to white and its parent is set to nil. Then time is initialized to 0. Then first check that this vertex is white color. Yes, this vertex is white color. Then this is considered as u. Then we perform the DFS visit. Then in the DFS visit, first change the color of u to gray. That is, it is discovered, so its color will be changed from white to gray. Then time will be incremented. Initially time is 0, so time will be incremented by 1. Then d of u, assign that time to d of u. So is this the discovering time of d of u is equal to 1. Then for each vertex v adjacent to u, that is, next we want to find out the adjacent vertex of S. Then it is A and B are there. Then here we consider this vertex and S to A. So we explore S to A. S is gray and A is white. So we check that this is U. We consider this is V. Adjacent of this is U and this is V. Adjacent of UV. And here what is the color of this? This color is white. So it's now its parent pi of V. Pi of V will be this parent arana. Who is the parent of this one? U. U means S is the parent. Assign that, and we will perform again recursively perform the DFS visit of V. DFS visit of V means here again recursively call this function. And now color of U, this is color. This color of U becomes, instead of white, it will be changed to gray, and timestamp will be incremented. Previous timestamp is 1. Now its timestamp will be incremented by 2, and D of U, now its time will be assigned to 2. And then again check the adjacent of this one. Here adjacent of this one is C. C's color is white. So its parent is assigned as A. A is now pi of V is assigned as U. U is now A. So its parent is assigned as UA. And again check DFS of V. V is now C. So DFS of C is again recursively call this function. Make the color will be changed to from white to gray. That is, it is discovered. And its timestamp, what will be the discovering time of this? Previous discovering time is 2. Now it's incremented by 1. So its time D of U will be now 2 plus 1, it is 3. And again find the adjacent of U. again it is the adjacent is B, so its color is white, so we will assign the parent as C. Pi of V is assigned as C. Then again recursively call this function d visit of u, then change the color from W to gray, that is already discovered, and timestamp. What will be the timestamp of u of d of u? Here previous it is 3, then incremented by 1, 4. So now it's 4. So we assign d of u is 4. Then again for each vertex v, next is adjacent vertex is S, but its color is now gray. So we can't do this procedure. So next color of u becomes black. So its color u means here this color, B's color become black, change its color to black, and timestamp will be incremented by 1. So last timestamp is 4, now it's incremented by 5, and that will be finished. It's converted to black means it is finished time. So that 5 will be assigned to f of this value, f of b. F of b will be 5. Then again recursively goes to this step, previous step. So here 5, again timestamp will be, its color become changed to black. Then there is no adjacent to this one, so its color become black, and timestamp will be incremented. Last timestamp is 5, so it will be incremented by 1, 6. That will be the time of this one. So this time will be 6 now. The F finishing time of C is 6. Then it's again move to backward. So here S A C. So here finishing time is 6. So again backward, move backward. So there is no adjacent one. So its color become changed to black, and timestamp will be incremented. 6, last timestamp is 6. So it will be incremented by 1, 7. So 7 is assigned to phi of A. F of A is equal to 7. Then again goes to here S. Move to S. S there is no undiscovered node is here. So all nodes are visited. So its color is changed to black. Then timestamp will be incremented by 1, 7 to 8. So this is the finishing time of S. So all nodes are visited. Then time complexity. So in the following figure, the solid edge represent discovery or tree edge, and the dashed edge shows the back edge. And furthermore, each vertex has 2 timestamps. The first timestamp records when the vertex is first discovered, and second timestamp records when the search finishes examining the adjacent list of a vertex. So this is an example. Initially, here U, V, W, X, Y, Z. We are starting from U. Then U indicates first timestamp 1. Initially first it discovered, then its timestamp is 1. Then next one is adjacent of this one. Either we can select U or V, X. Any one of the adjacent vertex we can select. നമുക്ക് ഏത് വേണമെങ്കിലും സെലക്ട് ചെയ്യാം. ഫസ്റ്റ് ഇനീഷ്യലി അതിൻ്റെ ടൈം സ്റ്റാമ്പ് 1 ആയിരിക്കും. ദെൻ നെക്സ്റ്റ് നമ്മൾ വി ആണ് സെലക്ട് ചെയ്യുന്നത്. വി സെലക്ട് ചെയ്യുമ്പം ടൈം സ്റ്റാമ്പ് ഡിസ്കവറിങ് ടൈം എന്ന് പറയുന്നത് ഇതിനേക്കാൾ ഒന്ന് കൂടുതലായിരിക്കും. ദാറ്റ് ഈസ് നൗ ഈസ് ടൈം സ്റ്റാമ്പ് ഈസ് 2. ദെൻ നെക്സ്റ്റ് നോക്കുക. നെക്സ്റ്റ് വിച്ച് വൺ ഈസ് ദി അഡ്ജസൻറ്റ് ഓഫ് വി? വിയുടെ നെക്സ്റ്റ് അഡ്ജസൻറ്റ് 1 എന്ന് പറയുന്നത് വൈ ആണ്. സോ ഇസ് ടൈം സ്റ്റാമ്പ് വിൽ ബി 3. ദെൻ നെക്സ്റ്റ് അഡ്ജസൻറ്റ് ഓഫ് y is this x. So x timestamp will be 4. Then adjacent of x is v. Then its color is changed, already changed because it is discovered. So its color is gray, not white. So all adjacent nodes are finished here. So we stop here and increment the timestamp. Then 4 plus 1 എന്ന് പറയുമ്പോൾ എന്തായി? 5i, 5 ആണ് ഇതിൻ്റെ ഫിനിഷിംഗ് ടൈം. സോ മൂവ് ടു ബാക്ക്വേർഡ്. Then y ൻ്റെ adjacent all nodes are finished. So time is 5 plus 1 6. Then again move to upwards. That is here 4, reach here 4. Then each time we visit, its color will be changed to gray. And 4 to 5. Then 4 to 5 here is finished, so its color become changed to black. Then here 3, there is ഇവിടെ ഒരു adjacent നോഡും ഇല്ല 3ക്ക്. സോ 3ൻ്റെ എല്ലാ നോഡും കംപ്ലീറ്റഡ് ആയി. സോ ഇറ്റ്സ് ടൈം സ്റ്റാമ്പ് will be incremented by 6 and it is finished. So its color become black. Then it's move backward again to when we reach to the time, finishing time is 7. Then again move to backward. So its timestamp is 8. So its color become black. So this section will be completed. Then we will start from another tree. So here we start from W. W has two edges are there here. So ലാസ്റ്റ് ടൈം എന്ന് പറയുന്നത് ഇവിടെ എത്രയാണ്? 8 ആണ്. സോ ഇറ്റ്സ് ടൈം വിൽ ബി ഇൻക്രിമെൻറ്റഡ് 9 ഈസ് ദി സ്റ്റാർട്ടിംഗ് ടൈം ഓഫ് W. ദെൻ ഇറ്റ്സ് കളർ ബിക്കം ഗ്രേ. ദെൻ നെക്സ്റ്റ് അഡ്ജസ്റ്റൻ്റ് ഓഫ് ദിസ് ഈസ് സെഡ് എന്ന് പറയുന്നത് ടൈം സ്റ്റാമ്പ് എന്താണ്? ഓൾറെഡി 3 വിസിറ്റഡ് ആണ്. സോ നമുക്ക് പോകേണ്ട ആവശ്യമില്ല. സോ ഹിയർ y വിസിറ്റഡ് ആണ്, ഓൾറെഡി ബ്ലാക്ക് കളറാണ്, ഫിനിഷ്ഡ് ആണ്. സോ നമുക്ക് അങ്ങോട്ട് മൂവ് ചെയ്യേണ്ട. നെക്സ്റ്റ് അഡ്ജസൻസ് എന്ന് പറയുന്നത് സെഡ് ആണ്. സോ ഇതിൻ്റെ ടൈം സ്റ്റാമ്പ് എന്ന് പറയുന്നത് 10 ആണ്. സോ 10ൻ്റെ അഡ്ജസൻ്റ് ഒന്നുമില്ല. സോ ഫിനിഷ്ഡ് ടൈം എന്ന് പറയുന്നത് 11 ആണ്. ദെൻ മൂവ് ബാക്ക്വേർഡ്. ഇതിൻ്റെ കളർ കംപ്ലീറ്റഡ് ആയിക്കഴിഞ്ഞാൽ ബ്ലാക്ക് ആക്കി. ദെൻ മൂവ് ടു W റീച്ച് ചെയ്യുമ്പോൾ 9 ആണ്. ഇവിടെ ഓൾറെഡി ടൈം എത്രയാണ്? 11 ആണ്. സോ ഇറ്റ് ഈസ് ഇൻക്രിമെൻറ്റഡ്. സോ 12i. സോ ഫിനിഷ്ഡ് ആണ്. ഇറ്റ്സ് കളർ ബിക്കം ബ്ലാക്ക്. So 9, so 10, then is 11, then backward is 12. So ഇങ്ങനെയാണ് നമ്മൾ വിസിറ്റ് DFS ട്രാവേഴ്സൽ ചെയ്യുന്നത്. എപ്പോഴും DFS ട്രാവേഴ്സലിൽ നമ്മൾ ചെക്ക് ചെയ്യുക. ഫസ്റ്റ് വിസിറ്റഡ് ആകുമ്പോൾ അൺവിസിറ്റഡ് നോഡാണെങ്കിൽ വൈറ്റ് കളർ ആവും. ഫസ്റ്റ് വിസിറ്റഡ് ആകുമ്പോൾ അതിൻ്റെ കളർ ഗ്രേ ആവും. ദെൻ അത് ഫിനിഷ്ഡ്, അതിൻ്റെ അഡ്ജസൻറ്റ് വെർട്ടിസസ് എല്ലാം കംപ്ലീറ്റ് ചെയ്ത് കഴിയുമ്പോൾ, വിസിറ്റ് ചെയ്ത് കഴിയുമ്പോൾ ആ നോഡിൻ്റെ കളറ് എന്താണ്? ബ്ലാക്ക് ആകും. അപ്പോൾ ഓരോ ടൈമിലും വിസിറ്റ് ചെയ്യുമ്പോഴും ഡിസ്കവറിങ് ടൈം ഇൻക്രിമെൻറ്റ് ചെയ്തുകൊണ്ടിരിക്കും. അത് കംപ്ലീറ്റ് ചെയ്യുമ്പോഴും ഫിനിഷിംഗ് ടൈം ഇൻക്രിമെൻറ്റ് ചെയ്തിരിക്കും. Then there are 3 types of edges are there mainly. What is the analysis of DFC? DFC analysis, it visit is executed. The for loop is executed total number of edges times for a directed graph, and an undirected graph it is 2 times of the edges. So initialization, we need to initialize each vertex initially, so that will take a time of order of v. So total time of DFC is also order of v plus e. So BFS also it will be order of v plus e. Then classification of edges. There are mainly 4 types of edges are there in this graph. First one is tree edge, and second one is back edge, and third one is forward edge, and fourth one is cross edge. What is a tree edge? A DFS tree has an edge. A edge in a DFS tree is called as tree edge. So when we draw a DFS, then the tree has an edge. That edge is known as tree edge. Then back edge. Back edge connects a vertex to ancestor in a DFS tree. If there is a tree from A to B, C, then there is a path to here. Then if it is connected to an ancestor, then this is known as back edge. So we note that if it is a self loop, then it is also known as back edge. Then what is a forward edge? Is a non-tree edge that connects a vertex to the descendant in the DFS tree. If a edge is connected to a descendant, then it is known as forward edge. Then it is not a non-tree edge. Then another one is cross edge. Cross edge is any other edge in the graph. There is an edge except from the forward edge, backward edge, and tree edge. The other edge is known as cross edge. It connects vertices in two different DFS tree or two trees in the same DFS tree, neither of which is ancestor of the other. So for example, here it represents this is a back edge. This edge indicates the back edge, that is from the node to its ancestor. And here this is another edge is forward edge. There is an edge from this to this. This is forward edge. This edge is not considered in this tree. In our tree, there is only this edge. So here it is a non-tree edge. Is denoted from the node to its predecessor. Predecessor. Then here it is a cross edge. Cross edge indicate the different. This is a one tree and this is another tree. So it is connected to using cross edge. Here also this is a back edge. Self loop is represented by back edge. So parenthesis algorithm, when we consider all u and v, then always discovering time is less than finishing time. When we consider all node is discovering time is less than is finishing time, and neither of u and v is a descendant of the other. Then d of u less than d of v less than f of v less than f of u. V is the descendant of u. That means discovering time of the descendant is greater than the discovering time of its parent, but finishing time of descendant is less than the finishing time of his parent. This is another example. Here we are starting from S, source vertex എന്നാണ് സ്റ്റാർട്ട് ചെയ്യുന്നത്. S1. Then next adjacent vertex നോക്കിയാണ്. Z ഉണ്ട്, W ഉണ്ട്. Then we are selecting here. Z is selected. So here starting time is indicated by 2. Then next adjacent is W ഉണ്ട്, Y ഉണ്ട്. We are selecting Y. So Y's discovering time is incremented by 1. So it's 3. Then nearest of Y is 4. So X. So X ന്റെ discovering time is 4. Then next adjacent എന്ന് പറയുന്നത് ഇതാണ്. ഇത് ഓൾറെഡി വിസിറ്റഡ് ആണ്. ഇറ്റ്സ് കളർ ഗ്രേ ആണ്, അതുകൊണ്ട് നമുക്കൊന്നും ചേഞ്ച് ചെയ്യേണ്ട. ദെൻ നമ്മൾ ബാക്ക്വേർഡ് വന്നു. സോ ഇറ്റ്സ് ഫിനിഷിംഗ് ടൈം. ഇത് കളർ ബ്ലാക്ക് ആക്കി. ദെൻ ഇസ് ഫിനിഷിംഗ് ടൈം എന്ന് പറയുന്നത് 6 ആണ്. 5 + 1 6 ആയി. Then again backward. ബാക്ക്വേഡ് വന്നു, ദെൻ ബാക്ക്വേഡ് വരുമ്പോൾ നമ്മൾ ഓൾറെഡി ഇതിൻ്റെ ഒരു നോഡ് വിസിറ്റ് ചെയ്തിട്ടില്ല, W വിസിറ്റ് ചെയ്തിട്ടില്ല. സോ ഇങ്ങോട്ട് പോയി, കംപ്ലീറ്റഡ് അല്ല. സോ ഇത് പോയി ഇവിടെ ഇൻക്രിമെൻ്റ് ചെയ്തു 7. ദെൻ ഇതിൻ്റെ ഓൾറെഡി എല്ലാ നോഡും വിസിറ്റഡ് ആണ്. സോ ഇതിൻ്റെ ഫിനിഷിംഗ് ടൈം എന്ന് പറയുന്നത് 8 ആണ്. സോ റിട്ടേൺ വന്നു, ഇവിടെ 9 ആയി. ഇതിൻ്റെ എല്ലാ നോഡും വിസിറ്റ് ചെയ്തു, സോ 9 ആയി. ദെൻ തിരിച്ചു വന്നു 10. സോ ഇതിൻ്റെ അഡ്ജസ്റ്റൻ്റ് ഒന്നുമില്ല, ഓൾറെഡി എല്ലാ നോഡും വിസിറ്റഡ് ആണ്. ദെൻ നെക്സ്റ്റ് നമ്മൾ ഇതിൽ ഈ സെക്ഷനാണ് വിസിറ്റ് ചെയ്യാത്ത. ദിസ് ഈസ് അനദർ ട്രീ. സോ നമ്മൾ എന്ത് ചെയ്തു, സ്റ്റാർട്ട് ചെയ്യുന്ന ആറിൽ നിന്നാണ്. ആർ ഈസ് ടേക്കൺ ആസ് ടൈം സ്റ്റാമ്പ് ഈസ് ടേക്കൺ ആസ് 11. സോ ഇതിൻ്റെ അഡ്ജസ്റ്റൻ്റ് ആണ് ദിസ് 2 നോഡ്സ്. സോ ഇതിൻ്റെ നമ്മൾ ഫസ്റ്റ് വിസിറ്റ് ചെയ്യുന്ന ഈ നോഡാണ്. സോ ഇറ്റ്സ് ടൈം വിൽ ബി ഇൻക്രിമെൻറ്റഡ് ബൈ 12. ദെൻ ഇതിൻ്റെ അഡ്ജസ്റ്റൻ്റ് നോഡ് ഓൾറെഡി ഓൾ ആർ വിസിറ്റഡ്. So its finishing time is 13. Now it returned back. So it's one of the node is not exploded yet. So come to here, U is not exploded. So its time stamp will be incremented. So its discovering time is 14, and it has no adjacent vertices. So its timestamp again incremented by 1. So 15. So this is the finishing time, and return back to here, and its timestamp will be incremented by 1, and its total timestamp finishing time is 16. So this is the traversal. Then interval of this discovery time and finishing time of each vertex corresponding to the parenthesization based on this parenthesization is shown here. Here first is starting from S. So 1, 2, 3. First we represents the timestamp from starting from 1 to 16. Draw here. 1 to 16 is drawn here, and each vertex is represented within the timestamp. So here 1, S is start from 1 and it is end here 10, when 10. This one S. Then next one is Z. Z start from here and in 9, end in here. And Y is 3 to 6. And W is X is 4 to 5. And W is 7 to 8. T is 11 to 16. And V is 12 to 13, and U is 14 to 15, like this. Then this is the parenthesization. According to the parenthesization diagram, based on the discovering time and finishing time, we are represented as a 2 trees. And here we represented the edges, classification of edges as here. So these all edges here is represented as a tree edges. This is known as tree edge. And the backward edge, here there is a edge from X to Z, that is represented here. There is an edge from X to Z, that is edge known as back edge. എന്ന് വെച്ചാൽ ഇവിടെ നിന്ന് അതിൻ്റെ പാരൻറ്റിലേക്കാണ് പോയിൻ്റ് ചെയ്യുന്നത്, അൻസിസ്റ്ററിലേക്കാണ് പോയിൻ്റ് ചെയ്യുന്നത്. സോ ഇറ്റ്സ് എ ബാക്ക് എഡ്ജ്. ആൻഡ് ഹിയർ W എന്ന് പറയുന്ന ഒരു സെപ്പറേറ്റ് ട്രീയുടെ പോർഷനാണ്, ആൻസിസ്റ്റേഴ്സിലേക്കല്ല. ആൻസിസ്റ്റർ എന്ന് പറയുന്നത് ഇതിൻ്റെ ആൻസിസ്റ്റർ ഇങ്ങനെ വരുള്ളൂ. സോ ദിസ് ഇസ് നോട്ട് ആൻ ആൻസിസ്റ്റർ ഓഫ് എക്സ്. സോ there is an edge from W to C. This edge is known as cross edge. Then another edge here, S to W. This is S to W. So pan to child ആണ്, so it's known as forward edge. And here this is another tree and this is another tree, so there is an edge from this node to this is known as cross edge. And here this U and V are not ancestor or predecessor, so this is also a cross edge. And there is a U to T. that is known as back edge. സോ നമ്മൾ ബാക്ക് എഡ്ജ് എന്ന് പറയുന്നത് ചൈൽഡിൽ നിന്ന് പാരൻറ്റിലേക്ക് ഒരു എഡ്ജ് ഉണ്ടെങ്കിലാണ് നമ്മൾ ബാക്ക് എഡ്ജ്. അതുപോലെ തന്നെ പാരൻറ്റിൽ നിന്ന് ചൈൽഡിലേക്ക് ഒരു എഡ്ജ് ഉണ്ടെങ്കിൽ അത് ട്രീ ആവാൻ പാടില്ല, ട്രീ എഡ്ജ് ആവാൻ പാടില്ല, അങ്ങനെ ഒരു എഡ്ജ് ഉണ്ടെങ്കിൽ ദാറ്റ് വിൽ ബി നോൺ ആസ് ഫോർവേഡ് എഡ്ജ്. സോ next, application of DFS. Mainly DFS we perform on unweighted graph, then it will create minimum spanning tree. DFS and BFS generate a minimum spanning tree for all pair shortest path tree, and we can detect this cycle in a DFS. If we get a one back edge during DFS search, then there must be one cycle, and it is used to find path between two given vertices. And we can perform topological sort, which is important one, which is used to scheduling job from given dependencies among jobs. So topological sorting is done using DFS algorithm. And another application is find strongly connected components of a graph. These are the two main application. One is topological sort and another one is strongly connected, finding strongly connected component. These are the two important application of DFS. What is strongly connected component? If there is a path from each vertex to every other vertex that is strongly connected, then that is called as application of DFS. That's all about DFS traversal. Thank you.